show you how to run the diagnostic test in STATA. For linear regression, econometrics models are generally based on some hypothesis that residual terms are normally distributed, heteroskedastic, and non-autocorrelated. To validate and trick model, you need to check all those three hypotheses that are hidden behind econometric model. This video will show you first of all how to run normality test, and then we will demonstrate and illustrate how to run heteroskedasticity test, and finally we will show you how to run and interpret non-autocorrelation test. First time you are watching one of my video, do not hesitate to subscribe to the YouTube channel and activate the notification bell in order not to lose the next video, and do not hesitate to let me a thumbs up. Make sure to know that all info we are making is helping you improve your skills in statistical model for social sciences. So let us start with diagnostic of normality test. The first step is to run the linear normality test in STATA, estimate the model. So we use the command res in order to run a regression in which we have as dependent variable GGP, and independent variable that we have in our database is gross fixed capital formation, general government final consumption. We have gross fixed capital formation, so we will add also a variable called general government investment. We have three independent variables in our model. So we click on OK, and we see that the result of our regression are now available. Also, both variables in our regression that are gross capital formation and general government final consumption. The second step in our model, our skewness test, is to predict a result. So to do so, we need to run the prediction of residual by using the command predict followed by space, and then we are going to give to our residual. So and then comma and then type C in order to tell STATA that we are going to predict the residual of the last estimated equation. So then click on OK, and our variable residual has been generated. So to run the linear regression test, just type the command SKTest, which stands for skewness test, SKTest, followed by the name of the variable that we are going to test. The variable is residual. Then click on OK. We can see that the result of our residual test are now available in STATA, and we can see that the p-value of our skewness kerasis test for normality is 0.2736, which is more than 5%, meaning that our residual are normally distributed. So coming back into our heteroskedasticity test, which in other terms mean the constant of variance of error terms. So to run the heteroskedasticity test, we need first of all to run your linear model. So in this tutorial, so we will run the command rec for relation. We will put our dependent variable, which is here the GGP, materializing the production, and followed by the independent variable that we have in our database. We have gross fixed capital formation, we have our government final consumption, or our government investment. So we keep these three independent variable model, and then click on OK. You can see that the result of our linear regression model are now available. So we can analyze the result by looking at R square or significance of different coefficients, but the aim of this tutorial is just to analyze the heteroskedasticity of the linear regression model in STATA. You just need to type the command het test, het for heteroskedasticity and test. So while you have typed this command, after running your regression analysis, then click on OK, you'll see the result of your heteroskedasticity test, which of breadth and pagan. So we have a null hypothesis which is constant variance of error terms in homoskedasticity. So we accept the null hypothesis because the p-value of our test is more than 5%. 5% is a threshold that is usually used in social sciences in order to analyze and to make a hypothesis test. So as our p-value is more than 5%, we just accept the null hypothesis, which is that our error term are homoskedastic, or the variance of our error term is constant. So it's a good information because alongside homoskedasticity test, which is one of the hypotheses, you should check at the normality and non-autocorrelation of your error term before validating your model. The error term autocorrelation test using STATA is quite simple. We will run a regression and show you how to use a linear regression result in order to run the non-autocorrelation test in the residual test. So let's start first of all with estimation of linear regression. So we will run rec, command rec, followed by a dependent variable, which will be here a GGP in current local currency. As independent variable, we have gross fixed capital formation, general government investment, percentage of GGP, all those variables. So we then click on OK, and we have the result of our linear regression. Regression in this case is not purpose, so we'll try first of all to predict our residual terms. So just use the command predict and give a name to our residual. We call them residual terms, and then comma and r to say to STATA that variable that we are going to predict is residual, and as we have just run a linear regression, the residual that will be predict will be the residual of our linear model. We then click on OK, and you can see that a new variable has been generated called residual terms. That is the residual terms of our just run model on GDP and the impact of some variable like gross recoverable formation, general government investment, and general government final consumption on the GDP. So as we have predict our residual terms, we need to set time data because autocorrelation have sense in time series data, and as well we have time series data, so we set our time series variable by using the command gset followed by the name of our time series variable, which is here. Then we click on OK, and our time variable is set from here 1982 to 2018, which is the horizon of our data. So last step is to run a model with our residual term. So we will regress using our command reg. Our dependent variable in the regression will be residual terms, and independent variable will be a log value of the residual term. So we'll use L dot residual term for log 1 residual term. After that, we will use log 2 L dot L2 dot residual, and finally we will include our third log 3 residual, and we will estimate the model. And in our model, the most important thing to log is the probability of fissure. Probability of fissure gives the global significance of our model. We give global significance of log value of error terms. The test of autocorrelation aim is to test whether or not log value of GCP significantly influence the current value. So as we can see, our probability is 0.000. That leads to the rejection of null hypothesis, which is that our coefficients are null. So interpretation is that our error terms are correlated and is not good for linear regression, because in a estimation of linear regression by least square, one of the hypotheses is that the error term must be non-autocorrelated, and hypothesis is violated in our case. In the future video, we will show you how to correct this autocorrelation using, for example, the generalized square or other transformation in order to correct a non-autocorrelation term. So that's it for this new video, and if you have not yet done, do subscribe to the YouTube channel as well as activating the notification bell in order not to lose my next publication. As do not hesitate to let me thumbs up. It will be a pleasure to know that all efforts we are making are increasingly improved to our level in statistical model for social sciences. So anytime soon for another video.